Greetings. In this one, I'll be talking about derivation of the formula, or how to get to the formula of kinetic energy over some other formulas. Alright, so those other formulas again have their derivations, but let's say I will work with work and energy in general, as is described, and I will get to the formula for kinetic energy based on the mass of the object and the velocity of the object. Alright, so first of all, it's important to realize what work is. Work is force over distance. So if 100 newtons is applied for 3 meters, gets multiplied together and gives 300 joules, which are the units of work. But at the same time, those are also units of energy. Why? Because 100 joule, some force over some distance multiplied together gives the amount of work done. But at the same time, what is needed for that work to happen is energy. So if the question was posed in the way that how many joules of energy are needed in order to apply a force of 100 newtons for 3 meters, well, that will be 300 joules. So in this manner, in this aspect, work, energy are replaceable. So from now on, I will start using the formula for work right here, alright? But you can imagine the energy behind it. So work is F times S, but at the same time, F is m times A. So F is equal to m times a, mass times acceleration. That's a way, it's from one of the Newton's laws, and I presented it in previous videos in other examples that actually solved real life situations or particular experiments, and this was used, but here it further expands this formula and helps us get to the formula for kinetic energy. So it's one of the steps, and the only realization really is that force equals mass times acceleration. Alright, so with that out of the way, I can further rewrite the rest that hadn't been changed. And now what came from that is work is equal to mass times acceleration times distance. Alright, but now I can rewrite distance in terms of acceleration and and time. Alright, so how to do that? Well, S is equal to 1/2 at squared. Alright, S is equal to 1/2 at squared. Therefore, this S can be replaced by 1/2 at squared right here. W equals m times a times 1/2 at squared. Now I will collect all the terms together. So a times a, that's a squared. Now what came from this is 1/2 m. I'll put the 1/2 in the front, 1/2 m, and then a times at squared, that's a squared t squared. Alright, so this is already getting us almost to the end, to the final formula for kinetic energy. So how to get that? Well, 1/2 m still stays, and at squared, a squared t squared is like at all of that squared. But at equals to v, alright? At equals to v. So where does this get us? Well, that's 1/2 mv squared. And this is the precise formula of the kinetic energy in terms of mass and velocity of the object that is concerned.